Welcome to lesson 4. Here I'm going to tell you the process of interfacing a Bluetooth module with Arduino. Till now, you have learned to control so many things. But if you can control things using your smartphone, then it will add an extra flavor to your learning. For me, that will be great for this course. So I'll show you how to interface a Bluetooth module. But before that, let's discuss some technical specification of Bluetooth technology. Bluetooth is a technology which is based on IEEE 802.15.2 standard of wireless personal area network. Mainly, Bluetooth uses a peer-to-peer network if you want to send some files to your friend's phone, then simply connect the two phones together using Bluetooth. The network will have no server and no client. It's a point-to-point communication. Even the limitation is you can't broadcast your files to many such phones. So Bluetooth is more like personal rather than public. That's why we use Bluetooth to transfer data to known devices. And broadcast technologies like Wi-Fi is used as hotspots for sharing internet connection to many users. That is one of the primary difference between Bluetooth and Wi-Fi. Let me show you the specifications. Bluetooth uses 2.4 GHz band of frequencies. The transmission technique is frequency hopping spread spectrum. In this method, the sender and receiver gets in sync first. How? They start communicating with a channel for a certain time period, then hops to another channel, then hops to another channel, and the list goes on. The timing of communicating in a channel got synchronized at the start. The benefits of using this technique is data speed and quality. As the communication is not happening for a long time in a single channel, so it's very unlikely to catch a noise. The data speed is 1 Mbps for classic Bluetooth 2.0. The range of communication is around 10 meters. And Bluetooth technology is now updated to BLE. There is an updated version of Bluetooth, that is version 4.0. BLE stands for Bluetooth Low Energy. It consumes less amount of power and the range is higher. That is more than 10 meters. Normally the range of BLE technology is around 50 to 60 meters, which is ideal for battery related applications. As it consumes less amount of power, BLE is ideal for battery related applications. In DIY market, there is HC05 module which works in Bluetooth version 2. There is HM10 which works in Bluetooth version 4. Both are low cost devices and easy to interface with Arduino. In this lesson, we will interface HC05 with Arduino. HC05 as a module has 4 working pins: VCC, ground, RX and TX. RX and TX are receiving and transmission lines. So when we interface it with Arduino, we must connect the RX of Bluetooth pin to Arduino's TX pin and TX of Bluetooth to Arduino's RX. That's the simple trick you have to follow. So what Arduino will transmit will be received by the Bluetooth and vice versa. In Arduino, there is only one pair of RX and TX at pins 0 and 1. But that hardware UART is connected at the USB port. Still, we can use that, but I'll show you a different approach. There is a library called software serial. This is a built-in library. Using this, we can create a virtual UART in any other pins. Once created, the pins will behave as another pair of transmitter and receiver. It's very simple. It is more like creating another serial object, which you have already learned in serial communication. The syntax for this is you have to add the library's header file in your program, that is software serial.h. Then at the first line, just write software serial. Both the S is in capital letter. Then give it a name. I have given my serial within bracket 9, 10. By this line, this will create a RX-TX pair at pins 9 and 10, where 9 is RX and 10 is TX. Rest of the functions will be same as serial object. Like you can call your virtual serial dot begin. You can call your virtual serial dot write dot print dot println. Like that you can do. For a better understanding, I'll perform an experiment on both way communication between my phone and Arduino. How will I do that? I'll send L to switch on the LED and send N to switch it off. Then if I send L from my phone, the LED will be on and the device will notify our phone that LED is on by simply writing LED is on. If I send N, the LED will be off and the device will notify. To perform this experiment, one app must be installed if you are following my method. And I have written the app's name and the author. You can find this app in your I did it for my Android phone, so you can find this app in Google's Play Store. Now let's see the circuit. The circuit is very simple. Here I have connected the Bluetooth TX pin to Arduino pin 10 and RX pin to Arduino pin 11. According to that, Arduino pin 10 should be configured as RX and 11 should be configured as TX. We'll do that in program. VCC is connected at 5 volt and ground is at ground. Now let's make the connections. So this is my setup. As you can see, I'm using one Arduino board and this is the blue color LED which I have connected at pin 12. I'm not using a resistor, but when you do that, please connect a resistor. This is my breadboard and here I have connected the HC05 with 4 wires. So let's look at this HC05. Let me rotate it. See, I'm using only 4 pins. As you can see, these 4 pins are RX, TX, ground and VCC. See, I don't need the pins state and enable. I need only these 4 pins to interface with Arduino. Let me connect this HC05 on the breadboard. So here I have connected. Now as per the order, the black wire is TX. Sorry, the black wire is RX, which I must connect to pin 11 because that is Bluetooth's RX and it should be connected to Arduino's TX. So it is connected to pin 11. The white one is Bluetooth's TX. It will be connected to Arduino's RX, that is pin 10. This is ground. The gray color one is ground and this purple color one is VCC. I am connecting it to 5 volt. Now I'll connect the USB cable. See, one green LED is blinking on the HC05 module. That means it is searching for Bluetooth network. Once it is paired with some other device, the blinking will slow down. Now let's write the code. I have already written this program and saved it with the name of Bluetooth. So as you can see, I have included the software serial library at the first line. See, I have included software serial library. Then I am creating an object. Sorry, I am creating an instance of software serial. So software serial, and my instance name is Bluetooth. So this Bluetooth will behave as an object throughout my program. So what I have written is software serial, then Bluetooth within bracket 10 comma 11. So 10 is RX here. Let me write it in comments. 10 is RX and 11 is TX. As per my connection, this is the right way to define. Then I have defined the LED at pin 12. And within void setup, what I have written is I have configured LED as output, and I have fixed the baud rate of this virtual UART named Bluetooth. Bluetooth.begin at, and the baud rate is 9600. In that way, the Arduino is opening a virtual COM port at pin 10 and 11, which can receive and transmit data in 9600 bits per second. That is the meaning of this line. Now come to void loop. What I have written is if Bluetooth dot available is greater than 0, that means if this Arduino board is receiving data at pins 10 and 11 through HC05, then this if statement will be true. Then it will go inside if statement, and I have initialized a variable called val, which is a character type variable. It will receive what it will store the data which is received at pins 10 and 11. So what I have written is char val is equal to Bluetooth dot read. So once the the character is stored in this val variable, then I'm checking if val is equal to small l, then digital write LED is high. That means make LED on and notify the Bluetooth device that LED is on. Simple. Else if it receives small n, then digital write LED low and notify the Bluetooth that LED is off. This is the simple program. If val L, then digital write LED high and notify LED is on. Else if is val N, then digital write LED low and notify LED is off. This is my simple program. So now I'll upload this program and let's see the output. Arduino is at COM5 and now I'll upload. This is my phone screen. I am using X recorder to record this screen. So let me go to home, then reopen. So this is my app, Serial Bluetooth Terminal. Let me open it. It opened. Now I'm enabling my Bluetooth. Let's see. Now this is the new device my phone found out. And now I am pairing with HC05. Usually the pins are 0000 or 1234. I am giving 1234 and it got paired up with HC05. Now let's come back to the app. So devices HC05. Now it is connected to HC05. Now what I'll do is, now I'm able to send data because the HC05 is connected to my mobile. Now let me drag it to this position. Now I'm typing L. See, the device is communicating. It is showing LED is on, and you can see the blue LED is on. Let me send N. LED is off, and see the device is notifying it. Let me do it one more time. L, send, the LED is on. See, I'm sending N, the LED is off. So this is the process. The both way communication is done using this app. I'm sending data to Arduino. I'm sending, rather you can say, commands to Arduino to switch on LED, and it is doing it perfectly.